Okay, in this video, I'll be doing the decision tree examples, and the first example goes as follows. Sarah King, president of King Electronics Incorporated, has two designs. Options for her new line of high-resolution monitors for CAD workstations. The production runs production run is for 100,000 units. Design option 1. It's and we can just say 0.9 probability of yielding good monitors. 0.9 of yielding what? Good monitors. And then per 100. And I need you to pay attention on something very critical. So now it says 0.9 has a probability of yielding 60 over 100 good monitors. Then they come back and say they give us the probability of the remainder of this, which is the 0.10 yields good, okay, and a 0.9 probability yield 65, and it's still good monitors. Okay. However, in this probability of yielding good, we need to appreciate that 40 over 100 it's bad monitors under this bracket. That's the reality of it. And then under this one, 0.1, 65 are good, whereas the remainder of 35 should be bad. Then this design will cost $1 million. Okay. Then design B has a probability of design B has a probability of 0.8 that will yield, meaning it will produce 64 good units, and a 0.20 probability that it will yield 59 59 units per 100. This design will cost, so now we're having a probability of 60, we're having a yield of 60 over 100 of good products, again 65 over 100 of good product. Now, this is your design A. For design B, we're having what? Uh, 0.8 probability that 64 over 100 goods will be good, and then obviously the remainder will be bad. Which is 36. Okay, and you need a zero point 0.2 here. A 59. The probability of zero point 0.2 will yield 59 over 100, and 41 over 100 will be bad, and the cost is 1 million. Cost is 135, which cover only that, which will cover only that, 1.50 million. Okay, good or bad? Each monitor cost the same price, good or bad? Each monitor cost $75. And then, however, the good monitors will sell at $150. Good monitors will sell at $150. So the selling price is 150. Then bad monitors are destroyed and have no salvage value. We ignore any disposal cost in this problem. However, we need to appreciate the fact that what are they trying to analyze here? Two designs, okay, and the production is okay, and then their options, okay. So what are they looking at? This is profit basically. You are looking at profit margins. You want to to look at the profit. I don't know why they're not talking about the profit, but you already seen something very critical. The 150 and the 150 and the 75. So now, what is your profit per screen? It's 150 minus 75. So now 75, which is the cost, 150 minus 75, removing the selling price, we are left with 75. That's the price for that's what you're gonna spend for good products, for these products. So that's your 75. And also, so basically 75 here, also this one 75. They supposed to be taken care of because of you've spent 75 on the bed material. Then we need to draw the tree. Option A, option B, option A. So now we have, they are both good products. None of them is bad. They're both good products. Keep that in mind. Okay. So here it's 0.8, 0.2, 0.9, 0.1. Okay. So now we're doing our calculations. Uh, so this is something that we need to kind of address very fast to avoid long run calculations. But we can still try and see, because this is bad products. They need to be subtracted from the good products. So now let's look at this now. All right. So this, ignore this, please. Ignore this. The 0.9 yet at the moment. Ignore it. So we're going to say 60 over 100 multiplied by 75 multiply by, how many units did you produce? 1 million. And then 1 million. That's your 1 million there. Actually, that's 100,000, not even 1 million. 100,000. Okay. And that's your cost. Obviously, this is your profit margin. We haven't yet looked at the cost. So you can just close bracket minus the other one now. Minus the 40. 40 over 100. Multiply by, remember, whether good or bad, you paid $75. Multiply by 75. Multiply by 100,000. The cost of design minus, I would like to write 1 million like this. I would like to write 1 million there. Right. The one below this is answer's gonna come here. The one that has to come here now is this the 0.1. All right. So open bracket 65 over 100 multiplied by 75 multiplied by 100,000. Close bracket minus that is 35 85 over 100 multiplied by 75 multiplied by 100,000. Close bracket minus 1 million. $1 million. Which $1 million? This one. So this is our profit margin. This is our scrap margin. And then this is our design margin. Then you have this now, and you also need to write here equals sign. Close this one. Right. Then 64 over 100 multiplied by 75 multiplied by 100,000. Close bracket minus 41 over 75, over 100 multiplied by 75 multiplied by 100,000 minus 1 million, not 1 million, 1 million 350. Then you close there, then you need to be ready to write there. Right. Then now on this one, we are having what? A 59 and a 41, which is going to be 59 over 100 multiplied by 75 multiplied by 100,000, and then close bracket minus open bracket. Okay, why am I using 41 here? 59 and 41. Well, that is 36. This one is actually 36, ladies and gentlemen. Apologies for that. 36. Oh, yeah. And then this one becomes a 41. 41 over 100 multiplied by 75 multiplied by 100,000. 100,000 units minus 1350000. Then close the big bracket like that. Then you're gonna get your answer. Don't forget that I said that this 75, it's not the same 75 as this. This is 75 of a cost, which is this 75 of a cost, because we are saying profit is profit is cost to sales minus cost. So this is your cost. then this is your profit margin, and it's coming there. This one is coming there. I hope this makes sense. Okay, now we need to do the calculations. So on the calculations, we are saying, Lord, what happened now? I just placed my calculator on top of my table and something started to move, but it's not a problem. 60 multiplied 60 divided by 100 multiplied by 75, which is the profit margin, multiplied by the 100,000, which is the number of how can I put it? The number of the good products. Now we're looking at the bad product. So 100 multiplied by 75 multiplied by 100,000 minus 1 million. The answer is 275. So 0.927500 close bracket equals to times 0.92475000. That's our field we are going through here with it. And below, /65 over 100 times 75 times 100,000 minus 85 over 100 multiplied by 75 multiplied by 100,000 minus 1 million. Okay, I'm kidding. 1, 120, okay, 1 250, which is equals to multiplied by 0.1, is 1 equals to 125 rand plus 2475 123. So obviously you need to connect it there. Then it becomes design 1 is 2.6 hundred, yes, it becomes 600,000, it becomes 2.6 million, right? Then the next one becomes now 64 over 100,000 multiplied by 75 multiplied by 100,000 minus 35 over 100 multiplied by 75 multiplied by 100,000 minus 150,000. But why the value is negative? This is a million, first of all, so that's supposed to be a million. Okay, minus 13500, and the value is positive. 8, 2, 5, 0, 0, 0, 0. Okay, and 0.8 plus 2 times 0.8. 66000. Then now this side, 59 over 100 times 75 times 100 now minus that 41 over 100 now multiply by 75 multiply by 100 now L minus 13500. Then my value is 0. Then this one is 0. Then coming forward, we're coming at margin of so you can see that this one is yielding better outcome. Although the price difference is exorbitantly high, but yeah. Okay, now I need to do some checking. I suspect my calculator might have given me wrong information. So when I redo it again, this section here, I don't think this is correct. This value here, it's not correct. I don't know why I'm getting this value, but when I redo it again, I get 500,000. So this is supposed to be 500,000, and therefore it will affect this and it will affect that. So my calculator says this is 500,000. And when I carry on and say multiply by 0.9, I'm getting a 450. And when I multiply by, when I add the 2, then I'm getting 5. 7, 5, like that. And the better design, of course, that yields better profit is this one. So I'm going to jump straight to a problem or that requires the similar calculations so that I can pay it immediately. And I think this is the only problem that will require the same calculations. So the problem is problem 5.27. So MacBurger Incorporates wants to redesign its kitchen to improve productivity and quality. 3 designs called Design K1, K2, K3 are under consideration. No matter which design is used, daily production of sandwiches at typical McBurry restaurant is 4 500 sandwiches. A sandwich costs 1.30 to produce. Non-defective sandwiches, meaning the ones that were not defected, they cost an average of 250 per sandwich. 2 rand 50 per sandwich. The non-defected ones. The good ones, you can sell them at this price. But the good and the bad, they're produced at the same price rate. Defective sandwiches cannot be sold and therefore are scrapped. However, they are part of your cost because you spend money producing them. The goal is to choose a design that maximizes the expected profit. So the example we have done previously was supposed to say this statement to maximize the expected profit at a typical restaurant over a day, over 3 day, 300 day period. Design K1, 2, and 3 yield or cost 100,000, 130, and 180 respectively. These are their costs for each design. Under design K1, now we're writing our info. K1, there is a 80. This could be in percentage basically. Probabilities are a measure of percentage, something that you guys don't know, although we just say 0.8. So, but you can say 80% chance. So 0.8 chance that uh, chance that 90 of out of 100 sandwiches are non-defective, meaning they're good. These ones are good. So I want us to now immediately notice that 10 is bad. 10 is going to be considered bad. And now the same K1 0.2 has a chance of 70 out of 100 sandwiches being good. Opposite of that, which is 30 over 100, become bad. Under K2, so here, highlight. And K2, 0.85 and 90 of 100 are bad. And then 50, with a probability of 0.15, 75 out of are good, and so on and so on. So like let's do this one first. K2 twice, K2, then we have what? 0.8, 0. No, The 0.85 has 90 that are good and has how many? 10 that are bad. Actually, it said no. Why am I? K2. K2, there's my K2 here. Let me use a different pen. Cannot be making mistakes. If you make mistakes like I am now, you are killing yourself, basically. You shouldn't make such mistakes. Okay, that's a 90 out of 100. Okay, so it becomes 90 here, K2. Okay, let me just go back to my black pen. 90, right? So this one becomes a 10 out of 100. So I was right, basically, but I didn't have confidence to say I was right. This one is 0.5. Then, which is 75 over 100. And then, which you are getting a 25 side over 100. And K3 is 0.9 and 0.1. Then each probability has chances of 95 over 100, 95 over 100, and the bad is 5 over 100. And this one is 80 over 100. K3 or 80 over 100, and the bad is 20 over 100. Then the cost for here it's 100,000. Then cost from 130, and the cost is 180. So now once you have this data, you are moving in the right direction. The next thing now you must do is figure out the other costs that are involved, cost implications. Then we have 300 days. We have cost of each sandwich, and then we have 500 sandwiches. And we have also now the price margin. It's we are selling each, let's say profit for instance 2.50 minus 1.30 equals to 2.5 minus 1.30 is 120. So for the profit side, this is what you're looking for. And for your cost side, this is what you're looking for. You don't necessarily do the sales that much. It will trick you the 1 year sales. Okay. Then you come to design your decision tree. This is K1, K2, and K3. Then K1, 2, K3, 0.8, 0.2, 0. 0.85, 0.15, 0.9, 0.1. Right. So for all of them, now we do this. Okay. So in a big bracket, in a small bracket, and 90 over 100 uh, multiplied by this is a profit side, good side. So we're going to sell them. We're going to make a profit margin of 1.2 multiplied by the how many are they? The 500. Yeah, 500 multiplied by 300. Okay, then we minus and we do the same thing with the 10 multiplied by 1.3. This is a cost side because of with the bad parts, bad goods. If we didn't have the bad good, we were now just subtract and focus on the sales only. And just minus our total cost. But because of we have wasted products, now we need to accommodate. They're not part of the profit. We need to accommodate them this way. 1.3 multiplied by 500 multiplied by multiplied by 300 minus 1 million, 100,000. Close the bracket. Don't calculate it yet. The steps has significant. The steps should have significant number of marks than your answer. Then here we have what K2, which is 75 over 100 multiplied by 1.2 multiplied by 500 multiplied by 300 close bracket minus this is going to be 35 now or 25. Yeah, it's 25, not 35. 25 over 100 multiplied by 1.3 multiplied by 500 multiplied by 300, 300 days, 500 sandwiches, 1.3 cost of each sandwich, minus 100 thou, 100 thou, then close bracket, you must write your answer here, you must write your answer here, then we do the same thing now. Open bracket, which is K2, which is 90 over 100 multiplied by 1.2 multiplied by 500 days, sandwiches multiplied by 300 days, close bracket, and you have 10 over 100 multiplied by 1.3 multiplied by 500 multiplied by 300 and close bracket minus the cost, which is 130. That close the big bracket. Then come here, uh, open the big bracket, small bracket, and you say 75 over 100 multiplied by 1.2 multiplied by 500 multiplied by 300 close bracket minus I think this one, if it's 75, that means it's 25 again. But I need to be assured of something. Yeah, I did feel it that why did I write 75 here? 90 and 10. Save this one. You see now. I had a bad feeling. You say certain things you must just feel them that you've made a mistake. This one is excited to erase everything. Then 70, 80. Right. So now here we are having a 25 over 100 multiplied by 1.3 multiplied by 500 multiplied by 300 close bracket minus 130. Right, then obviously we'll have to close that big bracket there and 95 over 100 multiplied by 1.2 multiplied by 500 multiplied by 300 close bracket and bracket this side minus it gets a 5 over 100 multiplied by 1.3 multiplied by 500 multiplied by 300 close bracket minus 180,000 look at that, and then you want to write answers in between. Okay, then we are having 80 inside a bracket of 100 multiplied by 1.2 multiplied by 500 multiplied by 300 minus, it's starting to float now. I need to be able to still write an answer here. So I cannot just close myself in the corner. Yes, open bracket, 80 over 100 multiplied by 1.2 multiplied by 500 multiplied by 300 close bracket minus uh, minus 20 over 100 multiplied by 1.3 multiplied by 500 multiplied by 300 minus 180,000 and close the bigger bracket. All right. So now we need to do all the summation. Okay, then all right, then we start with the first one. Open bracket. Uh, times 1.2 times 500 times 300. Okay, minus 1.3 times 500 times 300. 1.2. In this game, we need to make sure 1.3, okay, 10 over 100, okay, minus 100,000. And we're getting, so to be safe, 0.8, 42, 500 equals to times 0.8 equals to 34. All right, and then we come to the next one, which is 0.7 multiplied by 1.2 multiplied by 500 multiplied by 300. Right, and then 300, no, 0.3 multiplied by 1.3 multiplied by 500 multiplied by 300, and then 0.7 there, 1.2, 200, 1.3, 0.3, okay. All right. And we have a 67,000. Okay. 67,000 minus 100 now. We get a negative 32. So 0.2 negative 32, 50 like this, and then times 0.2 is equals to negative 6.5, which is going to be plus 34.5. Then you are left with 28 now here. We're left with 28 now. So okay, so you need to review this. Might have made a miscalculation. 84 now minus 6. So the answer is actually so it's actually 27. Not comma. Okay, but the comma is still fine. I've like this 500, yeah, 27,500, yeah, which is 27,500. Don't forget that it's 27,500. Okay, so now 0.85, no, open bracket I'm wondering if I can show the calculations here, but I'm not used to this calculator so that you guys can see what I'm doing. I'm not used to this calculator. Keep that in mind. Where is the scientific? Okay, how must I put it? Okay, because we don't need the 85 now, right? So, open bracket with our bracket, uh, 0 point number, 0.9 multiplied by 1.2 multiplied by 500 multiplied by 300, and then close bracket, then minus open bracket, uh, 0.1 multiplied by 1.3 multiplied by 500 multiplied by 300, then close bracket. 0.9, get that to 500, 300 minus 0.1 multiplied by 1.3 multiplied by 500 multiplied by that. Okay, then we find this answer equals to, okay, something is happening I don't like, is 3. So our value was actually 142. So 142 minus 180. So 142, 500 minus 180 is 12,000. Then 0.85 open bracket 12,500, which is equals to 0.85, 10, 6, 2, 5. Okay. Then now let's go back to that calculator. Uh, Open bracket, 0.75 multiplied by 1.2 multiplied by 500 multiplied by 300, close bracket, minus open bracket. Hey, that is not wrong. Right. You calculator guys, I can't deal with this. Uh, 0.75 multiplied by 1.2 multiplied by 500 multiplied by 300 close bracket minus 0.25 multiply by 1.3 multiply by 500 multiply by 300. Okay. Equals to 86250. Uh, it's a low number, which means I need to just verify. Okay, this side 0.75. It's fine. And 2.25 is fine. 1.3, 500, 300. Okay. So it's a small number. When you minus it from 130, now we're getting a negative value of 43%. So it's going to be 0.15 multiplied by negative 43750. 43750 multiplied by 0.15. Then we're getting our answer as a negative 6562.5. So this is plus 10625. And we're having it as a 4062.5. It's very low. I need to verify my calculation. And it is correct. Okay. Then now we're doing the last one. Now open bracket 0.95 multiplied by 1.2 multiplied by 500 multiplied by 100, close bracket minus open bracket 0.5 multiplied by 1.3 multiplied by 500 multiplied by 100. And we're getting a small number also. When you get small numbers, you must check 0.5. Okay, check. Minus 180,000. Getting a big number, 0.9 multiplied by negative 106,500 equals to multiply by 0.19. I mean, wait, oh, 95, 95. Okay, makes sense. 0.9, okay, which becomes negative 95,850. You come below, open bracket 0.8 multiplied by 1, 2, 100, 500, close bracket minus 0.2, we say 0.8, yes. And then times 1.3 times 500 times 300. We're getting a nice number here. Okay, minus 180, but it's way below the cost. Negative 75,000, 0.1 times 0.1. This one at least becomes negative 7.5. And then you plus it by negative 95850. Then you get a negative. So this one needs definitely a verification also. 103350. Verify it very quickly. I need to check something. 95 there and 5. Sure. Okay, open bracket 0.95. Punching straight. Point 12 multiplied by 500 multiplied by 300 close bracket minus 0.5 multiplied by 1.3 multiplied by 500 multiplied by 300. Oh, the 5% is actually 0.05. Yes, yeah. And then we're getting around about 160,000 minus 1.8. And the answer becomes 18,000. So this is 4. So it's 18,750 multiplied by 0.9, which becomes around about 16,875. Then take negative 750, 7,005 get plus that. So which means it becomes now becomes 20,4,375. So I did two examples that are similar. Obviously, our best profit margin we can get is this one. Okay, so yeah, we've solved two exercises in regarding this approach. So and it took an hour. So I will obviously end the recording here, and I'll continue later with my recordings. I'll do another example, and I'll do exercises that are similar to that example.